so we're at a spreadsheet. Let's see if we can come up with some of these normal distribution confidence intervals. So I'll type X for my input value, and next I'll go to symbol, and I'll see if I can quickly find mu, click insert, close, and then I'll go find sigma as well from the same place, insert, close, and so now I have my X, my mu, and my sigma, and we'll go back with the same inputs we had before, which was a 10% return and a 20% standard deviation, and we said we'll look for a 0%. My Z is going to equal, and it's the distance between the mean and what I'm trying to target. Oops. And so that's going to be -10, but I need to standardize this by, well, the standard deviation, and I get this isn't a percent, this is a decimal number. And actually what I'm going to do is I'm just going to go to format cells, and I'm just going to do a regular number with 2 decimal places, and look at that. Okay, so now I can calculate this using 2 different functions. I can use the norm dist function in Excel, and so I'll do that. I'll do norm dist, and so this is going to equal norm dist, open parenthesis, and there's my X as an input, and there's my mean, and there's my standard deviation, and I'm not really sure what cumulative means. Let's click the function wizard, and this gives me a pop-up, and it says, okay, X is going to be the value for which you want the distribution. Mean is the arithmetic mean of the distribution, we got that. And this is the standard deviation of the distribution. And then finally, cumulative is a logical value. Okay, logical value in Excel is code for how Excel does the calculation. So it doesn't actually use this value in the calculation, it just tells Excel how to do the calculation. And we want the cumulative distribution function, we want the area under the curve. And so we can either type the word cumulative or we can type the word true. Let's see. Cumulative function, use true for probability density function, and false. So we can either use true or the word cumulative. And I click true, and I get, there's that percent we saw before, that 30.85%. And just again, to do this one more time, I can do norm.s.dist. I can do norm sdist equals norm.s.dist, and now I only have 2 inputs. I have my Z value, and again, true for cumulative. Close that, and I get the same value. Control C, Control Alt V for paste special, T for formats, and I get that same format in there. And I'm just going to color code these. My inputs are going to be green, and my outputs are going to be orange. And this is arbitrary, but I'll just always do this with my spreadsheets. And now note that this one just has a single input, the Z, and this one has the rest of the values. And again, there's no difference, you can do either one. And so what we've done is we've calculated the probability of the return being less than X. Calculate the probability of the return being less than X, and that's equal to this value. There's a 30% chance of a return that's less than X, and of course the probability, and I'll do Control C, Control V, and I'll just change this. The probability of the return being greater than X is just going to equal 1 minus that value. And now I can play with this. So now I have a model built, and all I need to do is just copy and paste. And because this referenced only the cells above it, this will do the same. Reference only the cells above it. And so I can just copy and paste, and now I have another model. And so I can play with other values. I can say, well, I'm not interested in a loss. I'm interested in how likely I am to have a 25% gain. Okay, so now how likely am I to have a 25% gain? Well, there's a 77% chance of the return being between -infinity and 25%, which means that there is a 22.6% chance of a return greater than 25%. Now note that it's not possible to calculate the probability of a return of exactly 25%. You have to have some range so that you can actually have some area under the curve. For at any particular value, the probability of it being exactly 25% is 0. The same way it's never exactly noon. It's 11:59 in some fraction of a second. Then all of a sudden it's 12 o'clock in some fraction of a second. So it's never the probability of a return of 25%. It's the probability of a return greater than 25%. And before we did that range where we said, well, what's the likelihood of a return between 15 and 25%? And we said, okay, so now if I want to know the probability of the return being greater than 15%, probability of the return greater than 15%, but less than 25%, well, I know the probability of the return being less than 25, and I know the probability of the return being less than 15, and so therefore, it's going to be this value. And there is the probability of a return between 15 and 25. Other things I can do, I can change the distribution of the return series. I can change the mean and the standard deviation of the return series, and I can come up with other things to compute. So what I'll do is I'll just copy and paste, and I'll bring this down here, and I'll say, okay, what if I have something that has a very high expected return, say 20%, but is really, really risky, say a 50% standard deviation. Now, how likely am I to lose money? Well, even though I have a higher expected return of 20% versus a 10%, because it's so much more risky, I can see that I have a greater probability of losing money. Or I can find something that is very low probability of return, very low expected return, let's say 6%, but then also has a low standard deviation, and I can look at this distribution.